Decision-making is an important part of any interactive system. In this fragment, you will see two examples of how a neural environment supports decision-making process. The first one based on the example taken from the book written by Robert Clement. In this example, the decision to purchase or not to purchase a small commercial airplane presented in the form of so-called influence diagram. Every node in this layer represents an active agent that could communicate with external world, collect data, and supply this data to the analytical layer, which could combine all factors, their weights, and calculate results. The second example, based on 3 years of experimental study, clinical decision-making process, which had been conducted in medical university in cooperation with Professor Kirill Toskin. Professor Toskin suggested reverse algorithm to diagnose abdominal problems. Here we have 4 simple disorders: appendicitis, hernia, constipation, and cholecystitis. As well, we have approximately 400 symptoms organized in traditional clusters: anamnesis, complaints, objective finding, and so on. During the examination process, which could be conducted partly as interview, partly as obtaining laboratories objective finding, the physician will permanently readjust probability of these disorders and would make a decision of what question or what test would be the most important for the current particular state of his or her knowledge related to this case. Every node in examination scheme is an active agent, which may collect data synchronously and provide it to decision layer. Based on this layer, system prompts the next most probable question, and the whole process continues until probability of a particular disease reaches the threshold level. This example presents a solution where the next question would be selected or generated based on the flexible and dynamic configuration of active and interconnected nodes that creates the unique vector that provides the pattern for making a decision. This system would try to ask the minimum number of questions to establish the proper diagnosis. This example shows one of the unique features of 256GL: ability to acquire knowledge from the expert, as well as from the process of gathering it through statistical, or other word, self-learning. Expert should provide structures, basic meanings, algorithms, answers, and other components required for conversation or decision-making. In this example, expert used Perl to program functional cards. Script from cards, then stored into the web service directory and could be used to provide response as a regular web service. That makes neural environment prepared for very easy incorporation into any web pages. At the same time, the history of conversation or any textual data related to the particular knowledge domain could be provided as an input to the system for self-learning. During self-learning, the system will improve its knowledge, and at the same time, it could find new words, new phrases, and ask the expert to interpret them. As you can see, all these green lines represent weighted connections automatically established during self-learning process. Later, any incoming words or phrases would activate associated nearest structures and nodes, and that will help to understand the meaning of current situation and provide information for predictive behavior. Considering the enormous amount of relations, one of the major goals of our editor is to visualize only useful information in clear structural form. This fragment shows the process of designing and interpreting the structure of dialogue between the human and the computer. Dialog flowchart is an important component of the whole interactive process. In this example, we are using HyperTalk active scripting environment which is similar to Perl or to JavaScript. Every node in this flowchart, we call them agents, has associated script that answer questions. Dialog flowchart can be fulfilled with different information. It also could be connected to SQL database and provide contextual response. What you see in this fragment, the dialog editor, the interpreter, and external scripts, they are three fundamental building components of 256GL development environment that allow to develop complicated interactive solutions. Ontology is the form of representation of human knowledge. One of the definitions of ontology, shared conceptualization and shared vocabulary, reflects the fact that we need something common to understand each other, and ontology helps us to systematize our knowledge and make it easy to understand the meaning. Ontologies include objects, sets, attributes, relations, and other components that could be organized in a very complicated networks. This movie presents example of one's individual ontology that include common knowledge, personal knowledge, business and professional knowledge, as well as vocabulary and a few grammatical rules. We are using special knowledge editor to build and navigate in the maze of interconnected objects. In this example, sets of basic objects organized in layers. As you can see, every single window popping up on the screen represents the layer with basic object belonging to it. In reality, ontologies could include thousands of layers, and our editor and our tools develop especially to navigate in that complicated environment. In this example, with a simple click, we are navigating into the deeper substructure of the concept, and then going back to more generic layer, and going inside another concept, and so on and so on.